deep learning. Okay, and primarily you may have talked about convolutional neural network. Is it fine? So you have done neural network, you have done convolutional neural network. But today we are going to talk about RNN and LST, that is recurrent neural network. Okay, so the question is how this is different from your neural network or convolutional neural network. For what kind of problems you are going to use this RNN architecture or LSTM architecture. So basically both these are used for the same purpose, but RNN has some disadvantages. I'll be talking about that what are the disadvantages of RNN, and then how LSTM helps you to solve that problem. Okay. Now, when you talk about neural network, I think what you may have learned, that is you have input layer, then you have one or more hidden layers, and then you have one output layer. Okay, so assuming that you have d number of nodes at the input layer, and at present I am assuming that you have only one hidden layer, so you think about that you have k number of nodes at the hidden layer and c number of nodes at the output layer. Every node of input layer is connected with every node of hidden layer, and then every node of hidden layer is connected with every node of output layer. Assuming that you have ith node, this is not working. Okay, no problem, no problem. Okay, so assuming that this is the ith node at the input layer and jth node at the hidden layer, you assume that there is a weight between these two nodes, which is given by Wji. And similarly, assuming that this is your kth node at output layer, you are connecting this jth node with kth node with the weight that is Wk. Okay. Now, assuming that you have each sample is represented in terms of d features, point to be noted. Each sample is represented in terms of d features. And if you are solving, let's say, 5-class problem, okay, you want to recognize A, E, I, O, U. So it is 5 class. So you are going to have 5 nodes at the output layer. If you are solving 10-class problem, say 0 to 9 numbers you want to recognize, then how many nodes you are going to have output layer? 10. If you are going to differentiate, let's say 100 types of samples, then how many nodes at the output layer? 100. Okay, so let's say you are going to follow such kind of representation. Okay, so you initially you are given a training samples. You don't know what are these weights. What you do? You start with the random weights, and then you pass the sample. Let's say the input is given by say x1, x2, x3, xt. You want to find out what is the net input reaching to this node, jth node. So how you compute? Wj1 x1, Wj2 into x2 plus Wj3 into x3 plus Wjd into xt plus some bias. Okay, let's say Wj0. So this is the net input reaching to this neuron. So you have, there is some input to the neuron, and I am saying this neuron will process. So after processing, it has to give some output. Okay, so how you find out what will be the output? So you think about that, okay, you are going to model this with the help of some kind of activation function. So you can use different kind of activation function. So you may have heard of sigmoid function, ReLU function, LU function, sine function. Okay, so you have different kind of functions. So I assume that this is the net input. The net input which is reaching to this neuron, jth neuron, is, I use the notation net j. So output of this jth node, I am saying it is given by yj. And this yj is nothing but, depending upon what kind of activation function you are using, you can compute f of net j. Is it fine? Now you have output at these neurons, middle layer, y1, y2, y3, yj. So all these are going as an input to this each one of this node. How you compute the input to this neuron? y1 into yk1 plus y2 into yk2 plus yn into yk okay, yk and plus some bias. So let's say this is nothing but net of k. So what is the output? So again, it depends upon what is the kind of output which function you are using. I can use any function. I can use g of net. It is some different function. I can use different kind of activation function at every neuron. No one stops me. Okay? But usually at same layer I use one kind of activation function to make our task simpler. So that doing coding is easier. Okay? So you use one kind of activation function. I can use the same activation function, can also be used at other layers also. But at present I am assuming that what is this activation function? F. Okay? So what is the output at these nodes? Zk will be given by f of net k, where I am saying output observed at this kth node is z of k. So you are giving the input, you are observing the output, that is your z1, z2, z3, zk. But you want that the output should be t1, t2, t3, tk. So if your z vector is different from t vector, then you have to change the weights. You have to change the weights. Okay, it means the weights which you have used for initialization is not good enough to classify the given input sample. So you are going to change, and I think you must have learned how you can change these weights. So you are saying that you can compute what is the net error at the output layer, and the whole objective is that I should be able to minimize this error, minimize this loss. Okay, and what is the best way of computing? So in mathematics, all of you may have learned one quantity which we say gradient of some scalar function. So you know what is error? You compute gradient of error. So gradient of error is a vector quantity. Remember this once. Gradient of error is a vector quantity. Vector means what? It has magnitude, it has direction. So what is the meaning of gradient of error? If you go through the actual meaning of gradient of error, it tells you a vector along which if you move, error will increase. What is gradient of error? Gradient of error is a vector along which if you move, error will increase. But what is your objective? Are you interested in increasing the error? No. You want to decrease the error. So what you will do? You just move opposite of that direction. So then what is your delta W? If you want to change some weight W, then delta W is given by minus of del error by del W. Then what is the role of this eta? Eta tells you this minus del J by del W is telling you along which direction I should move. But it is not telling you by how much I should move. Okay? So, it is estimation. Estimation may be correct, estimation may be wrong. So, at initially, your estimation may not be correct. But with time, you keep on improving your estimation. So, what is suggested that eta, initially, if you choose, you move along this direction, but that can take values between 0 to 1. What do you mean by 0 to 1? Same magnitude, or eta will what you do? Reduce. So I am saying 0.1 means I am moving in that direction only 0.1 times of that magnitude. Is it fine? Okay, this is very important. I am again stressing, okay, because if you can understand these basic things, understanding any deep learning algorithms will not be difficult. So I am re-stressing this particular fact. That's why I am revisiting this part which you may have already done. Okay. So what is delta W? Delta W is telling you by how much you should change the weight. Okay. And your eta is controlling by how much you are going to change. And in general we take eta to be between 0 to 1. Initially I take eta to be large. Large means around 0.2, 0.3, 0.1, okay? But with time, I keep on decreasing by, okay? Alright. So, I think I will not discuss the derivation part. So, you may have learned this. Now, we are going to talk about RNN. You have already learned neural network architecture. So why RNN? In artificial neural network, point to be noted, what is important point, what kind of problems you can solve. You can solve classification problem, you can solve regression problem. You can solve classification problem, you can solve regression problem. But what is the kind of data you should have? Labeled, okay, fine. Or regression means your regress value will be there. What else? What?
Unlabeled data also.
No. It should be labeled data because you are talking about supervised learning. What is the important point? The size of means the dimension of your each sample should be fixed, is same. Means your each sample is represented in terms of same size. 10 dimensional, 20 dimensional, 15 dimensional, 1000 dimensional, 2000 dimensional. Every sample of training data should be of same size. But in general you have many problems where the dimension of the data may be different. And let's see some of these problems. Somebody has tweet. Okay, he has used certain set of words while tuting, and now based on that tweet you have to tell whether it is a positive sentiment or negative sentiment. You may react corresponding to one policy of government of India. You are also reacting, you are also reacting, you are also reacting, but while you are typing, okay, the number of words used by you can be different from the number of words used by you or by you. Yes or no? So it is not of the same size. So even though it is a classification problem, you are saying it is a positive sentiment or negative sentiment, or you say neutral sentiment, but the sample is not described by fixed size. The dimension is not fixed. So how you can solve such problem? Okay. Second thing, let's see. Let's say on base of your voice, how you are speaking. How you are speaking. So I can find out whether you are under depression or not. So you are speaking, you can keep on speaking. You may have spoken only 10 sentences, this person may have spoken only 1 sentence, the other person may have spoken 20 sentences. Okay, but now after hearing those sentences, I have to figure out whether the person is in depression or not depression. It's classification problem. Or I want to just see stage of depression, stage 1, stage 2, stage 3. Okay. Now let's take another example. You have an image. I show you image, and now you have to tell what is happening in this image. So same image you can describe by 5 sentences, you can describe by 2 sentences. Or the 2 different images of the same size, one image can be described by 20 words, other image can be described by 15 words. Okay. Image size can also be different. So I am saying that the size of the input data can be different, the size of the output can be also be different. I am saying I eat mango. I am specifying. I am typing about I eat sweet mango. Okay. Further I go. I eat sweet mango which is yellow in color, or I can say some varieties. So can you see that I am describing something. So this sentence can be of 2 words, or it can be 3 words, or it can be 5 words, or it can be 10 words. All of us use Google Baba. Okay. Without that, now I think nothing can happen. Today also when I was coming from Dwarka, I was thinking how I should reach, so I take help of Google Baba. So many times I use Google Baba, so I start typing. I started writing India. Okay? It suggests you many different options. Have you seen this? Okay? So because corresponding to India, many information is there. So then, but I am interested what has happened between match, which is yesterday there was a match between India versus women's match, women's cricket match. So India versus I have written UAE. So again it's suggesting certain options. Okay, women's cricket 2024, 2023, 2000. So what I am talking about. So you have multiple set of options. So you want to develop such kind of system which allows user to choose one of this. Can I solve such kind of problem with the help of this artificial neural network? You don't have fixed size input. You don't have fixed size output. So you will see we can solve such kind of problem with the help of recurrent neural. Okay. So I am saying not all problems can be converted into one with fixed length inputs or fixed length output. So when you have such kind of problem, then in that case, so let us take one simple problem. You are giving some binary numbers which is consist of zeros and ones, and my question is that the number of ones, if it is even, the output should be 1. The number of ones in the binary string is even, then the output should be 1, else the output should be 0. So am I defining what should be the length of the binary string? So can I solve this problem? This is a classification problem. If I use artificial neural network, the number of nodes at the output layer will be how much? 2. But what about number of nodes at the input layer? I don't know. Because you can have your binary string of length 2. It can be binary string of length 5, 7, 9, 11, 13, 15, 20. It can be anything. So if I have to solve So you find that artificial neural network will not be able to give you the solution. Okay. So what we do, so I think I will explain with the help of this example. So I consider every input at a particular time. So when I say I eat, so there are only two words. So I is the event at t is equal to 1 and eat is the event at t is equal to 2. So in this case, my x1 is representing the input. So at t is equal to 1, I have given the input. So now you are going to be in state h1, and now at that state, what is the output? So I am saying output I will be observing is y. Okay. But now, so you just think I am typing I. It is going to give you many options. Okay. So now let's say my next input is eat. Okay. So at t is equal to 2. Input is x2. But eat also depend upon what is the previous word. Yes or no? Context is important. Okay. So the context is important. So in this case, how I model? So it is going to look into what was the earlier state at t is equal to 1. That will also go as an input to this module. X2 is also an input. Based on these two input, it is going to give output y. Now at next stage, what will happen? You will find that S2 will go as an input. X3 is my next input. Based on these, I am going to compute what is the output at t is equal to 3. Okay. So let's say if you have sample of length 3, I can compute what is the output at the various units y1, y2, y3. But in this important architecture, you have to remember this model H has weights which are same. It is going to be shared across the whole architecture. Okay? Means this module will have certain weights which will be same across the whole network. It is going to simply unfold. Okay? But it is going to consider two inputs. One input will be your input, and another is what was the state of last input. Okay, so can I model like this? Can I model like this? So at time t, the input is xt, and for previous input xt minus 1, your state was st minus 1. Those two will go as an input, and this module has connections depending upon what is the length of xt and what is the length of xt minus 1. Correspondingly, the weight w you have to learn. Okay, so if you have only one xt here and xt minus 1 is also of length 1, then how many weights you are going to have? 2 plus 1 bias. So you have three variables which you have to learn. But if you say that this xt is of length 5 and this your st minus 1 is of length 1 and your bias is 1, so 5 plus 1 plus 1, so 7. So how many weights you have to learn? 7. So depending upon the problem, you are going to have this. And now, so these are the two inputs. You will not be knowing initially weights, just like artificial neural network. You are going to compute what is the net input. Okay, so net input can be computed. You can think about w into xt plus w into xt of xt minus 1. This is some you can say scalar variable plus some bias. So now that is your input, and what is the activation function you are using? 10 hyperbolic. So what is the characteristics of 10 hyperbolic function? The output range will be between -1 to 1. While sigmoid function output is range between 0 to 1. Okay. So you can see that at time t, the input is xt and you are getting your, what was the state after the input of xt minus 1. What is the state? st minus 1. This is going as an input, and you are going to have output st. So you can think about this is a recursive architecture. This is a recursive architecture. Depending upon what is the length of the input, if you have on the length of the input is your 5, so then this has to be unfolded how many times? 5 times. If the length of the input is 20, then how many times this has to be unfolded? But this W which is describing this module is not known to us. Okay, and we are going to learn from the data. Okay. So you think like this. So at present I am showing for only when the length of the input is only 3. x1, x2, x3. This is my your W. W will describe this weight. So these two in h naught, initially h naught I consider to be, let's say, 1. Okay. So taking this input, can you compute what is the net input going to this activation function? Based on that, can you find out what is the output h1? Now, depending upon h1, so I have modeled st as this. I think this part is clear. Now, for a given st, what is the output? So I am saying again, we are using some kind of activation function, and let's say f of st. So what is the yt you are observing? That is your f of st. Now, as you have done in artificial neural network, for a given set of weights, you have given input, you know what kind of output you want. So that is ground truth, or target output is already given to you. In supervised learning, for every sample, target output is given to you, ground truth is available to you. Now, based on this, you will be able to find out what is the amount of error this network is making. So, what is the loss at this point? The loss I can compute, sorry. What happened? Okay. So, can you compute what is the, if your output here, you expected is GT1, but you are getting output to be Y1. So, can you compute what is the error?
Yeah.
So, error can be also of different kind, whether you are using square error, whether you are using mean absolute error, whether you are using cross entropy error, whether you are using Kullback level divergence error. So there are different kind of errors. Okay. So you can compute what is the amount of error at this point. Similarly, you can compute what is the amount of error at this point, and similarly you can compute what is the amount of error at this point. Okay. So if you have error, what do you do? You have to change the. Okay. What I told you, here in this recurrent neural architecture, this cell, each cell is described by same set of weights. So you are going to update weights at one go. Is it fine? Okay, this is a shared network architecture. So now let us see what kind of problem we can solve. I can classify restaurant review. Okay, and means restaurant review. But so someone is writing only 10 lines, other may be writing only 2 lines, the third person may be writing 20 lines, and now based on the review, you should be able to find out whether it's a positive review about this or negative. Sometimes you want to label between 0 to 5, because in general we see that label is given between 0 to 5. So scale you can decide. So if you are saying between 0 to 5, then it becomes a regression problem. But if you are talking, you are discretizing 0, 1, 2, 3, 4, then again it's a classification problem. You are saying only 0 and 1, then again it's a classification problem. Now, similarly, you want to talk about review of a given movie. These days, we look into IMDb to find out what kind of movie it is. Okay. Now, so this part I have described. So now let's see how I am going to solve sentiment classification problem. So about one particular hotel, so somebody is written the food is this. Okay, and ultimately I have to give only one output. And that output is what? Whether the what is the you can say ranking of that restaurant, 0 or 1. Okay, the quality of the food is good or bad. Okay, so here I am not interested in what is the output here. Can you see here? I am interested only in giving this output also. So at present this output is ignored for this problem. The output here is also ignored. I am interested to compute only one AND output. Okay. So for this what I will do? So H from different H, I will compute some kind of average H. Okay, or I can compute your sum of H, and that I will utilize for finding out error. Okay, is it fine? Because error can be because of each timestamp. So for considering this, what I am doing? I am computing all HIs using this HIs as a sum or average, okay, or median, okay, and then I'll be able to compute my loss function. Now similarly, let's think about image captioning. So in this image captioning, how you model? Initially you are given a image. Using CNN, what you can do? What you can do? One is you can do classification. You can find out different objects. Okay, you can describe each one of the objects. So once you are able to find out what are the different objects present in this image, then using the context I can describe what is happening in the. So for image captioning, what is the first part you are going to do? That given the image, I will do segmentation. Okay, and from using segmentation I can find out various objects present in the, and then I will find out their neighborhood, and in that, using that context, I will be able to describe what is happening in the image. So let's say I was able to find out 5 such objects. So I'll give these inputs one by one. Okay, so I'm going to use this, and then so if I give this, so I'll be able to by getting this inputs, I will be in one state. Okay, and then I'll be able to describe what will be the output. So I can describe that there is a dog sitting under the, you can say, mat. Okay, whatever is the activity taking place. So similarly, all the image can be provided. So what are the different kinds of problems we can solve using this RNN? One, feed forward network. For a given input, you want to have one kind of output, but that we solve using feed forward neural network architecture. But now what we can solve? Single input. Image is a single input, but you are going to have multiple output. So single input, multiple output. So the problem, one kind of problem is image captioning. What is another kind of problem you can solve? Multiple input, single. What is example? Sentiment classification. Okay? Or tweet classification. Okay? Then you have multiple input, multiple output. Multiple input, multiple output. You think about a video. So what is video? Can you think about, you have a set of frames. So each one of them is acting as an image. So you can give various input. So you have multiple input, and then you have to describe what is happening in the video. So a multiple input, multiple output. So you can solve such kind of problem using neural network. So then again another problem. Translation from Hindi to English. Okay. So what happens? So you have a sentence which has multiple words, and what is the output? You want to you translate from Hindi to English. So that is also multiple words. So you want to convert from multiple input to multiple output. Again, such kind of problems is solved using RNN. Okay. Now, as you have learned in the case of artificial neural network, that initially you don't know what is your weight. Then what you do? You start with some random weights. Okay, and then using gradient descent method, you are going to learn those weights. So what you do, based on initial weights and initial input samples, you are going to compute loss, and your objective will be to minimize the loss. Okay, and you use gradient descent method, okay, or some variant of gradient descent method to find out how to update the weights. Okay, so in this architecture also, just like artificial neural network, you have two stages. One is your forward computation, another is your backward computation. In forward computation, what you do? You give the input. Input is flowing from one layer to another layer, and at the end you will be able to compute what is the net output at the output layer. So this is your forward computation. Based on this output, you will be able to compute error. So this computation is computed in what? Forward stage. What you do in backward stage? You compute the how to change the weights, and that change in the weights is happening in the backward direction. Okay. So similarly here also we are going to use, first of all we will compute what is the net error using forward computation, and then we are going to use gradient descent method, and we will be updating the weights in the backward direction. Okay. So in this you are able to compute what is the net error. So after computing your error, you are going to find out what should be the change in the weights, and that you are going to compute in your backward. So what you are saying? You know what is the loss? W is fixed in all the cells. Okay. So you want to change the weights. So what is the formula you are going to choose? W is equal to W plus delta W. And what is delta W? Minus eta del error by delta W. So you are going to compute this. In this case, my error is represented by. Okay. But C is not directly function of W. You see that C is a function of Y and YGT, ground truth. But Y is a function of HT, and HT is a function of W. So using chain rule, you will be able to compute what is the amount by which you are going to change it. So how you compute delta C by delta W? So this is a function of YGT is fixed, is constant. So you are going to differentiate C with respect to Y, and then you differentiate Y with respect to W. But and here Y is a function of W. Okay. So now it's also possible that initially here there was only one hidden layer. There was only one hidden layer. But you can think about, you can have multiple hidden layers at t is equal to 1, at t is equal to 2. Okay. So now I am showing the example of that you have two hidden layers. So you have input. This network is described by weight W1. The output is Y1. Now this Y1 is going here, and some input is also coming from the previous time stamp that will be utilized for computing Y2. But weight here is given by what? W2. Now based on this Y2 in ground truth, you will be able to compute what is the loss. So how you will be able to find out weights? You have to change W1 and W2. So W2 will be changed like this, and W1 will be changed like this. But again, C is not a function of W1, C is not a function of W2. Okay. So you have to solve it using chain rule. Okay. So do I need to explain all this?
Yes, sir.
When you are going to have multiple, you see that this is your loss function at time t is equal to 3. So you are going to find out what is the change in your C3 with respect to W. This will also depend upon how your C2 is changing with respect to W. This is also depending on how C1 is changing upon W, and also it depends upon what is an input coming, because this H3 is taking input of what? H2. And this is here, this is taking an input of H1. So do you think that H3 will be a function of H2 and H1 both? Yes or no? So you find that if you want to compute what is your del CT by del H1, so you find that you have to compute this, yes or no? So you are saying it is a multiplication of many terms. And if each one of these terms is going to be very small, let's say 0.1, each one of these is of order 0.1, and there are such 10 multiplications. So 0.1 into 0.1 into 0.1 into 0.1, what will you get? 10 is to the minus 10. And this 10 is to the minus 10 is as good as 0. So this is also going to give a problem of vanishing gradient. Okay. Or you say vanishing explosion. When there will be vanishing explosion? When this term, each one of these term is what? More than 1. Okay. So in RNN architecture, this is the problem. That if you are going to have, you can say, long set of this time units, in that case, because of changing phenomenon, it will be as good as there is no change here. Okay, and it means there is no learning taking place in this network. Okay, then what is the solution? What is the solution?
Sir, like in the previous one where the change was more, so we used to decrease the learning rate. So can we like?
But even then, I'm saying even you are choosing eta to be small, but still the size of this delta W, this function is of order 10 to the minus 1, and multiplying many 10 to the minus 1 order term can give rise to a very small value. So it will vanish. So vanish at this initial. I think this particular part must have been told in deep learning architecture. That was the main problem. Multi-layer perceptron theory was there prior to 2000. And mathematically it was shown, demonstrated, proved that you can have, if you have many hidden layers, the performance will be better than when you have lesser number of, means what is the importance of deep and shallow architecture. So there was one research paper that was there in prior to 2000, that by using deep architecture you are going to solve problem much easily in comparison to shallow architecture. But still prior to 2000 none of us were able to use more than 2 hidden layers. Most of the research works were using either 1 hidden layer or 2 hidden layers, and it was because of what? Because of this chaining rule, because of this vanishing gradient problem. Okay. So what is the contribution of deep learning after 2000? It was how to remove, how to handle this vanishing gradient problem. Okay. And so one of the thing you may also have learned in CNN architecture is that what was the term? Can you see? For computing this is your del ht is a function of, you have to differentiate with respect to ht minus 1, ht minus with respect to ht minus 2, ht minus with respect to ht minus 3, h2 with respect to h1. Okay. So these terms are becoming very, very small. But if I don't make it small, let's say if this quantity is around 1, if it is 1, then after multiplication what will happen? Let's say all these are 1, 1, 1, 1, 1, or is it some constant? So what will happen? Will it be 0? Okay. So thinking of this, so we thought of that can we model like this, that ht is given as some function of ht minus 1 plus f of ht. So now if you differentiate ht with respect to ht minus 1, what do you get? 1. Okay, and that what you do in ResNet. That what you do in ResNet. Have you done ResNet architecture? ResNet architecture is one of the type of your convolutional neural network architecture. So you'll find that they have also used a skip connection, and with the help of that they are able to resolve this problem of vanishing gradient. Okay, so just remember this point. Can I model so that my st is behave as some st minus 1 plus f of xt? So if I can model like this, then I'll be able to control my vanishing gradient problem. And there we have introduced the concept of your LST. One is we are able to resolve this vanishing gradient problem, and there is another important point. What is another important point? See that since our beginning, when we have taken birth till now, we have learned so many things, and we have also forgotten many things. Which things we remember? कौन सी चीजें याद रखते हैं? Which are important to us. So our mind, our brain, neurons they are very intelligent. They know what to remember, what to forget. Because you have limited memory. And in this limited memory, you cannot keep all the information. So we are able to keep important information. So similarly, in this LSTM architecture, one of the important point is that when you have very long sentences, and you have to conclude from these long sentences, so you have to understand the context, but at the same time you should know that if there is this distance between the two words is very large, you may lose the context. But if they are important, then you must remember. So in what way I should be able to bring this part in my architecture so that I should know which part to forget and which part to remember. Okay, and see how beautifully in this architecture this has been suggested. These two things. Okay. So see, this is my, I think all of us use metro. Okay. You must have seen your conveyor belt. Many times this conveyor belt is also used in industry, where at different moment of a different time, a different kind of input is placed on conveyor belt, and then it is mixed, and then you prepare some new material. So while you are doing things, so let's say it is started, conveyor belt has started from here at t is equal to 1, you have put something, it has done some processing, it has removed certain things, and then you are putting something else, using this two, moving further at t is equal to 2, doing some processing, again you eliminate certain things, you bring certain things, and you do again some processing. भाई फैक्ट्री में यही तो होता है, जो बॉटल पैक आपको चीज मिलती है ऐसे मिलती है क्या? Okay, so there is a assembly line is being created. So I am going to present that part. So at present I am thinking about at time t minus 1, the output of this stage was given by st minus 1. You have xt is the input at time t. This is your weight of this cell. Now I want to know what is the net content you are getting. Okay? What is the net content you are getting? And now this content will be going through this activation function, and this will give you my output ht. Okay? So what you are thinking about, what is my ct? My ct is a function of ct minus 1 plus your 10 hyperbolic w xt of st minus 1, because st minus 1 w, you are going to compute this. So this is the net input coming. What is your ct? ct will be computed in terms of what was earlier content at t minus 1. So you are going to have this. And what is your st? st will be depending on what is the content at time t. So see, so when I differentiate this ct with respect to ct minus 1, what will happen? This will become 1. So this will be able to take care of overflowing problem, okay, or vanishing gradient problem. Now, I told you that in this architecture we should be able to have certain things where we should know what to remember, what to forget, what to bring new information, so that we arrive at new content. Okay, and for this I think I will do it. You think about, you have many cells, each one of cell has this kind of architecture. Now I am trying to explain each one of this. How you are able to bring the concept of forgetting certain things, bringing new information, computing new things, how you are able to bring this with the help of architecture LST. So every cell A in your RNN was of fixed kind, that is your 10 hyperbolic W of your xt into st minus 1, yes or no? So W was explaining that cell. In this case, you have many weights. So each weight will be doing a specific job. One kind of weight will be doing the job of what to remember, what to forget. One kind of weight will do the job of what to bring, okay, and then how to compute new information which are relevant corresponding to the given problem. So you think about, this is a kind of belt, conveyor belt. So at time t minus 1, the conveyor belt was having this content. After t, the conveyor belt will have information Ct. At this, it will be your Ct plus 1. So this conveyor belt is moving, and which time this information is keep on changing. And how you are able to change this information? So this part is doing the job of what to forget. Means which content you need to forget. And then it is important what to insert. Okay? And then you need to find out, combine this with transform xt, because you are getting some input at time t which is given by xt, and then so see that how you are going to do the job of forgetting. So you have the net input xt at time t. This is your previous state at t minus 1. This will, both this input is taken and it is processed through, means so this module has weights WF. What is the weight? WF. WF stands for forgetting. So weights corresponding to forgetting content. Okay. So WF into this vector dot vector plus BF is your bias. So this is a net input reaching to this neuron. What is the output? I am saying the output will be controlled by sigmoid function, where sigmoid will be giving output between range 0 to 1. So FT will be computed like this. Is it fine? Okay. So you have to learn separate weights for what contents to be followed. Then then we are going to talk about. So now you are talking about, for the same input xt and st minus 1, you are going to compute, okay, what content is important. And for that I will be learning separate weights, and that will be given by what? WC and DC. Okay? Input is same, but the job of weights is to find out what to which content is important, which bits to insert into the next stage. Okay, and then what you are going to do, you are going to compute new content. So the new content depends upon old content. This old content is controlled by forgetting part. Means out of the content which was available at t minus 1, which part I need to forget, that will be taken care by ft. So ft into ct minus 1. And then you are computing this ct dash based on the input, what content is relevant, what parts to be inserted, that you are going to compute with the help of it. Okay. and you are going to compute new content at time t. Is it fine? Okay. Now, once you have this, then you are interested what to be outputted at that time t, because at every time you are going to show some output. So what should be the output? So again, for that you need to learn a separate weights, that is W, O, B, O. Okay, input is same. Okay, and you are going to compute what should be output, and you know what is the content at time t. So this is Ct. So using this, you will be able to show how to scale this output, how to scale my output. So what are the steps involved? I think I'll explain. So first part is based on the input st minus 1 xt, you are going to learn weights wf and bf so that you remember what to forget. Then what content should be inserted, what content should be brought in. Based on that, you will be able to compute what should be the new content at time t. So now you know what should be the new content at the conveyor belt at time t, and using that you will be able to find out what should be the new state at time t. Okay. So this can be written in terms of an algorithm. Okay. Once you know what you are doing, so what you say that you are given a set of samples. So, and let's say you are going to compute for time capital T. So at t is equal to 1, you are going to compute what is the forgetting component F1. Then you are computing I1. Then you are computing C1, and then you are computing C1 tilde. Then you are this is the content at time t is equal to 1. Then you will be knowing what is the output at t is equal to 1, and then what is the state at t is equal to 1. Now knowing this can you compute at t is equal to 2? So you can unfold, keep on unfolding, and then after that you will be able to know what is the loss. So there are what are the different kind of problems you are solving? One is your multiple input, single output. So you are computing H1, H2, H3, Ht. Based on this, can you compute what is the average value of Ht? Based on this, can you compute what is the net loss? And then knowing your loss, can you compute what is the how you change the weights? Problem is solved. What is another kind of problem? You have single image, multiple output. How you will do this? You are going to compute H1, H2, H3, Ht. At each stage you are going to compute your loss function, and then what is the objective? That you want to minimize each one of these loss. Again, you have to learn what is that common weights W, but in this case you have three kinds of weights: forgetting weight, your input weight, output weights, bias. So you are going to learn this. What is another kind of architecture? Multiple inputs, multiple outputs. Loss will be computed as this. Okay. So this is the architecture which you can visualize. The only difference between RNN and LSTM is the following. In RNN, the cell structure is very simple. It is not thinking about what to forget, what to insert, what are important, what are not important. It's not talking about. But what is the problem with RNN? It suffers from the problem of vanishing rate or exploding problem. But this you are able to resolve, because the way you have conceived this problem, can you think this Ct is a function of this. So if you differentiate Ct with respect to Ct minus 1, you will find that this Ft is going to be some constant number, and which is not small. Okay, so this is not going to create vanishing rating problem. Okay, so you can solve this one-to-many problem, you can solve many-to-one problem, you can solve many-to-many problem, and you can solve your many-to-many for name entity recognition also. Okay, so I think I'll give some time for question answers. Okay, so what we have done, okay, we have talked about how your RNN and LSTM is different from ANN. Then we have seen that what are the different kind of problems we can solve using this RNN and LSTM. We have also learned what is the problem of RNN and how LSTM is able to resolve. So now, but the question is, what are the hot research in this area? Okay, so these are, all these slides are not my slides. I have taken from different sources, references I will be telling you. Okay, but what I have done, by going through various kind of materials, I am able to prepare something which can be of some importance to. Okay, so there is no research contribution in my this slide. Okay, but yes, we have done some research, but this is not, this FDP is not for research. This FDP is for your basics. Okay, but if you are interested, I can tell you one of the important. I can tell you two important areas where you can do some kind of research. One is your how to solve this optimization problem. Because ultimately you have to learn weights. Okay. So when you talk about your gradient descent method, one of the disadvantages of gradient descent method is that you may stuck into local minima. So how to come out from this local minima? So people have suggested many kinds. They talked about stochastic gradient descent method. People are talking about many variants of stochastic gradient descent method. Okay, so using first order statistics, second order statistics, they are suggesting some algorithm. But can you also think about some method which can definitely perform better than one which are existing? Another is your area which many people have already explored and trying to explore, but this is still an open research area. That is your attention. Okay, because there are certain content in the text which are salient content, means very relevant content. So how you should be able to come out and find out those salient content present in the text, salient content present in the image, salient content present in the videos, okay, with less computational resources. Although there are certain architecture transformer based, okay. So transformer based techniques have been suggested, which have come out to be very good, which looks into both, you can say, low level features and global level features. Okay, means low level features, global level features in what? It can look into local contents and it looks also into global contents. Okay, but at present the computational resources which is required for running transformer is cannot be run in such simple computer. Okay, so with this I stop my presentation, and if you have any queries, you are welcome.
If you have any query, then ask the questions. Online participants also. No questions?
No questions, it means then you have not understood anything or you have understood everything. Okay, so both are not possible.
Yes.
So, okay.
So we use LSTM for two major purposes, as you told. So the one is the loss in the gradient, right? And the other one is what to forget and what to remember. So the forgetting and remembering thing comes when we have a very large input, right?
When the length of the input
is very large.
Yes, yes.
So is there any specific criteria or experiment we can do to identify what kind of length? Because so in LSTM the complexity increases so much as compared to the simple RNN, right?
Sure.
So how to differentiate, like when to take LSTM?
So I think there is no such thumb rule, because it depends upon problem to problem. Okay. Because sometimes when you talk about speaker recognition, okay, so you can have one audio clip which is of 100 seconds. Well, you can also have an audio clip of only 1 second. Okay, because you are not fixing the size. The moment if you fix the size, you say that okay, my audio content will be of only 1 second, then definitely you can think about it, okay, I'll use your simple RNN. But if it is a variable length and this contains longer duration videos, longer duration your text, longer durations your paragraph, then your LSTM comes into picture. But most of the cases, what are the problems we are solving these days? We are passing on one chapter and you are asking the machine to summarize the chapter. So do you think it is your 4-line or 5-line or 10-line chapter? So similarly, video. You want to summarize video. What is happening in the video? So again, the content of the video is large. You don't have video of only 5 frames. In general, you have video of what? 100 to more than 100 frames, yes or no? Okay. So that's why for most of the problem, you find that LSTM is the better. You can think about what is the choice between LSTM and transformer. But if I take my opinion, choice between RNN and LSTM, I'll suggest. You see, it's not very complicated. There we were learning only W and B, but here we are using what? WF and then W0 and then we are using what? WI and so these are the 3 kinds of different weights we are learning. Okay, and this cell structure is same. So it looks little complicated, but it's not.
Sir, in one of those slides, you mentioned that before this LSTM part, in RNN part, you said that because we manage the gradient and to prevent all that, then you came to saying that we will take an average of all the HI that we get from the hidden layers. If you could once come to that side,
So
that part. Yeah.
No, when I was talking about that part, the relevance was different. You can say context was different. When I was talking about this, I said when your problem is to solve many to one problem, you have many words and the output is only one. So in that case, at various time units, initially there is no output you are observing. But your states, you are H1, H2, H3, you are computing because they are being utilized by the successive cell. So, but your computation can go wrong at various stages. Means that H1 can also go wrong, H2 can also go wrong, H3 can also go wrong. Okay, and then because of this, any one of this wrong computation of HIs, your loss can be different, your output can be different. So to resolve this, what you are doing? You are computing what is the average of this HIs, or what is the sum of this HIs, so that based on this one single value, you will be able to compute what is the net loss. So here the objective was different. But when I was talking about chaining rule, where I use chaining rule, you
That
have
was in
many-
updating the weights. Chaining rules was in back to the
yes.
weights. So here, now you said that okay, if any one of those computations could go wrong, like H1, H2, or if it's n computations for all the H1, H, then taking the sum and then
because
averaging it will
you are
actually
not,
put
because
the-
at every time stamp you are not computing the output.
yeah, we are in computing the middle.
Your output
segment.
is observed at the last time units.
Yeah.
So the HIs which are computed at the previous time units, they can also be computed wrongly. Do you agree?
Yeah.
So you have to see that those are not getting wrong.
Yeah, but
Or anyone.
some-
So for this, yes. So this is the law of average behavior.
Okay. But sir, if
You
anyone
see,
is
let's say
wrong,
if you have, you see how this average behavior statistics gives you good result. In this India, okay, you have election, but if truly exit report is computed, exit poll, I think it can be go very correct. It can give you very correct information. but the way its samples should be taken, that should be done.
Uniformly.
You have, let's say, NIT Delhi. I want to compute average age of the students of this institute. And you, let's say you have 5,000 students. Finding out, first to know their age and then find out what is the average age of the institute can take long time. But if I take 5 samples from all the classes, even if I compute the average of this, that will found out to be nearly same as the actual average of the whole institute. But if I am doing sampling, then correct.
But
So here also the law of average behavior, because it's not in one run, you are passing on many samples. Okay, so because of this law of average, you will find that ultimately what will be computed, it will be to the actual.
So won't the successive cell will compute wrong if the previous cell has computed wrongly, because we are passing H2 to H3
No,
as well.
I am computing these. I am computing this.
Yeah.
But I am then computing one single value, that is H. Okay, and then based on this H, I am going to compute the loss function. Loss, how you compute loss function?
No sir, that is okay, but if H2 went wrong, so we are not ending there, right? We are calculating till Hn.
It is not only if I do it with the help of only one sample, then it may go wrong. But if you are using thousands of samples for computing this,
Okay, and then we have evidence here.
so then it turns out to be correct. Friends, let me tell you, if you start with some artificial neural network, you assign the weights, and you assign the weights, and you assign the weights. This initialization of weights can be different. But when you ultimately compute what is the accuracy of the model on the test data, for the same, for your data, you may give 92.3. For your, it is can be 90.7. For other, it can be 89.9. So there is not much variation. But there is a power of the algorithm is this, that even if you start anywhere from any weights, okay, few of you may be taking 20 iterations, other may be taking 40 iterations, the third one may be taking 100 iterations, but ultimately you will be converging to that weights. And mathematically I can show you that it is going to converge. What is your roots of x square in, if you solve x square minus 4 is equal to 0, what are the roots? Plus minus 2. But now you solve numerically. Okay. You may get value 2.00001, 1.999999999. Is it wrong result?
No, sir.
Is closer to. So when you are solving, I tell you one method, you get 2.0001, you are getting 1.9999, the other person may be getting your 1.999989, but it is very close to 2. So we consider this to be correct enough. Okay.
Okay, any other question? Online participants, any questions from your side? Online participants, any questions? I think there is no question.
No question. Huh? So thank you.
So thank you, sir, for your nice presentation.
But the learning will be more if you start implementing. You know? Because if you won't implement, there will be no learning. Okay. Take small problem and you solve, okay, you learn more.